Just wait a couple of seconds. There we go. Cool. All right, brilliant. Right. So what I think is a good way to start these, what I always try to think about at the beginning is what's in it for you, right? What can I focus on in these talks that are directly helpful to you? So today's talk is about, well, the short version is vibe coding, but I'm hopefully going to convince you that using an AI to program with is not very vibe-like at all, to be honest. Doing it effectively is not very vibe-like at all. So it probably should, this lecture is not really vibe coding, it's just programming with an AI. Now, why should you care about this? Well, I'm sort of assuming that most of you have got a computing background or interested in computing, computer programming, that's your career you're going towards or something like that. I think that AI programming is the first non-entertainment killer app of AI. And it will dramatically change the computing industry. I think this is almost certainly the case. And that's why you should care about it, right? Because I think it will be inevitable that you will have to care about it. And if you care about it earlier, then I think you could put yourself in a much, much stronger position. So, okay, what is my evidence for these claims? Well, I mentioned last week the psychological benefits of doing personal projects. I basically said, it's good for you, makes you happier, makes your life better, all these kinds of things. So I also mentioned that I've been doing personal projects my whole life. So my engagement with programming as spending a lot of time programming really started when I graduated. So that was like 2000. So about 25 years I've been doing this, where my spare time, a very large percentage of it was spent programming. So I have a huge number of hours programming. And I have tried to program all kinds of different things as different personal projects. And I've loved it a lot of the time. Why I started doing this, I don't know if I mentioned this already. When I graduated university, my first job was in the games industry. And I joined a games company, which was just a complete fluke in many ways. I just, out of the blue, contacted a games company who made a game that when I was younger, I thought was really cool. And they replied yes, and they gave me a job, right? That was completely crazy. It turned out the games company, which is called Mythos Games, they made a game called XCOM, and it was one of the greatest games of all time, and it was amazing to be hired by them. And one of the reasons I got the job was because they were going bust very rapidly, and I didn't know this. And so it was a hell of a first experience to get a job, my first job, other than the placement jobs. And it was kind of like a childhood dream. And then it was sort of like a childhood nightmare. So there were two things about it which weren't nice. One of them, obviously, was that it was going bust. But the other one was that I was significantly worse at programming than everybody else in the company. And there are a number of people who were hired at the same time as me. And we all actually went on to have, reasonably interesting careers in the local games industry. And one of the guys was called Dean, and he was an old hand in the games industry. And he had just gone from one exploding games company to the next. And I just latched onto him and learned as much as I possibly could from him. But one of the main things that I did was at that time when I realized that I was significantly inexperienced relative to other people, I just started programming a lot. And the way I would program it's fairly extreme in some ways. I would try to do these projects, personal projects, which I'll keep talking about personal projects a lot throughout these because I think it's so important. Um, so I did pick different things. A lot of it was vibes based. It was just like, this is something that I wish I knew how to do, and or something like that. And I would just try to program something. Wasn't usually more complicated than that. Wasn't like trying to make a product to be sold necessarily or anything like that. Just programming things. So what would happen is that um, I would do the day job. I would come home and I would continue to program on these other things. And this would tire me out. So basically every day I was doing more than I really could, and I was sort of deteriorating. And at the beginning of the project, I'd be the code would be really nice, it would be going quite well. And then as time went on, I would be less and less able to take on effectively difficult parts of the code. And so I would be starting to do easier and easier, slightly more mindless aspects of whatever I was doing. And that's kind of okay. And then I would fall below another level of energy. And in that case, things were sort of starting to be a mess. It's a little bit like being depressed or something. You're like, you don't have enough energy to do a bit of work without it sort of leaving a bit of a mess behind. Um, and then you reach a point where you can't even really program things. Partly your code base is a bit of a mess, and you're just so tired that one of the things I tended to do was to just sort things. It's totally crazy. I would just, create folder hierarchies, and I would just put stuff in them, all kinds of different things. But sort of psychologically feel like I was tidying up. And then I would recover enough. And typically I would start a new project and the process would repeat. And I did that for years and years and years and years. Now I did all kinds of cool projects, I learned all kinds of useful things. Um, Although a lot of the things that I worked on didn't necessarily last. Um, I gained a lot from doing it, and I gained psychologically and confidence, and eventually I passed the level of being the least knowledgeable person in games. And then gradually, because effectively I had a very high work rate, I became very experienced in games and could basically turn my hand to almost any part of game development. Um, a big part of that actually, which I'll talk about in general, is reading other people's source code. So the sort of levels of sort of skill and comfort that you get to in programming, and a very important one to pass is being able to read other people's code. Because all the best programmers, almost all the best programmers, don't write any books and they don't teach any courses. So the way to learn how to be really good at programming is to read the code of really good programmers. And one of the traits of being really good at programming is that the code that you write is easy to understand. And I often think of it like a Zen poem. It's like this beautifully minimalist code base. And it really captures in an understandable way the thing that you're trying to do. Middle experienced people, sort of more traditional, like 9 to 5 programmers, typically make code bases with a huge amount of code, a lot of which doesn't really do very much. There's a tendency to sort of overcomplicate things a lot, which I think you don't get with the very best programmers. So so this is kind of my journey, right? And so what's this got to do with AI programming? Well, obviously when AI came along, I didn't immediately pick it up for programming. What I did first was what I guess a lot of people did, because there was no Claude Code or any of these command line tools or Cursor, or at least they were very, very new and kind of pricey and things like that. So the first thing I did was I just used ChatGPT. I asked it to write something, and then I would sort of copy and paste the results back and forth. a very manual, doing really very small bits of code, really like a couple of functions basically, and that was all you could fit in the context window. Um, and it was cool. It was interesting. But even from the moment ChatGPT came out, what I wanted was, can I get AI to make a large thing, which is effectively what my hobby is, right? My hobby is making large amounts of software. Sometimes dealing with really large code bases. That's another form of training you can do, is take something that's really big. So once you can read code comfortably, the stage after that is to be able to deal with massive code bases. So one of the things I did in games was, once I could sort of read code and I could sort of I basically found other people's like GitHub projects. I got them running. I looked at the internals. One of the things I did a lot of was, I would get code that I thought was really cool, and I would basically extract the bit that did the work and leave all the other bits behind. So I was sort of learning how to, like a Formula One car, just take the bit that did the calculation and really like mess with it and make it my own sort of thing. So I did that with like a software 3D renderer. I did that with a physics system. I did that with 2D rendering. I did that with, eventually later on, I did that with like the Eclipse Java compiler, all these kinds of things, just sort of like, um, getting comfortable with big code bases. I read every game engine source code that I could find. All the internal ones in our teams, I just read the whole thing. So that's really, that again, these are all like very, very useful skills to have. So as soon as AI came along, I was like, I want to be able to do the things that I do in my hobby. Like I want to be able to do those with AI. And what I found was that the AI was just very unreliable, that it was so unreliable I couldn't really work with it. I only ever used it for effectively like leet code style problems where it was a very tricky algorithm and it could produce the result in one query and response. Okay. So that was cool. It was cool at that. But it was a little bit like computer vision or something like that, where you've got this cool algorithm and you're going, how can I use this cool algorithm? Like it's a solution in search of a problem. It's not a universal tool for doing stuff. And then and basically the models got better. And the models got better until Gemini, I think, was the first one, which had a big context window. And because it had a big context window, I could now make about like a 10,000 line code base, roughly. And the AI could sort of deal with that. There were like stages of mental degradation as it hit, I can't remember, maybe 5,000, 6,000 lines of code. And then after that, its performance started to get worse and worse. And then when it hit about 10,000 lines, it would typically, any change it made to the code would introduce a bug. So once you reach the point where every edit produces an error, you can no longer use the AI, basically, because you can't get the AI to fix anything, right? So it's very aware of this like hard limit on the complexity of the project, which was really small. And whenever I saw the demos that people were doing, where they'd say, "Oh, look at this great model. Look, watch it make like a little computer game or a little simulation or something." Every time I saw that, I was like, "Are you people actual programmers? Because like what you're showing is extremely fake, right?" So a lot of those demos are just massively fake. Either the requirements are really low, or it's not covering, edge cases and things like that. It doesn't really reflect what, an experienced software developer would be doing, and it doesn't really capture the actual problems that you face. And I always have this slight feeling, because I know that people who work in industrial AI research typically don't deal with code bases that maybe have very high standards to them, have been polished a lot for user experience, or larger, or any of these kinds of things. And so they do a lot of scripting in Python, and it's kind of like whatever will get the job done is fine. And that's what it feels like whenever I see an AI company like demoing their programming capability. I'm like, you don't understand what programming is, right? Like, why are you showing this off? So I felt kind of similarly, but I was very excited when Gemini came along because um, the 10,000 lines was enough to do something kind of cool. So that like in about a week, I would get about 10,000 lines. So we went from effectively 1 to 3 function calls to a week's worth of coding in 10,000 lines. But towards the end, it was very unpleasant, right? And the code base just, it was a huge file and it was very hard to navigate around. And it was, I was definitely hitting the hard limits on what you could do. And it was really just an experiment. And I was starting to think like, is everything that I make now going to have to be designed a little bit like Linux, right? Linux is made up of lots of little programs that are chained together. And that's what AI programming kind of felt at that moment. And then I started using Claude Sonnet 4. Now, Claude Sonnet 4 to me was a new milestone. So Gemini had the context length that it could deal with, like, in one question and answer, it could produce, 10,000 line, sort of a 10,000 line code base. And there was like embryonic beginnings of some kind of like, I'm just going to edit some of this file rather than give you the entire file back. ChatGPT completely died at that task. It would massively rewrite the code base every time in response to an answer. And so it was just an unbearable task of doing a merge every time it made a change. So I basically stopped using ChatGPT or OpenAI's models. I then went to Gemini, and then I basically moved on to Claude Sonnet 4. And Claude Sonnet 4 is smart enough that for me, it basically crosses the trough of disillusionment that I've been talking about. So what Claude Sonnet 4 can do is it can take a large code base and you can basically talk to it and it can find the part of the code that needs editing and edit that part. So that represents a completely transformative level of capability, right? And this is one of the things that's interesting, I think is really misleading about the AI announcements and the AI stages and launches, where somebody will go, oh, GPT-5 is not much smarter than whatever, like look at the numbers going up or whatever. And I'm sitting there going like, I know what this commercially important job is about. I know how to do it. And every model prior to this was either like completely useless, or in the case of Gemini, like if you designed the entire project around what the AI could do, then you could get something useful out of it. And then Claude 4 Sonnet was basically, I don't have to do that anymore. It's like I have a QLabber, I have a partner that is working with me who's a programmer, and I can now work on arbitrarily large, complicated code bases, right? So that was the moment, and it's taken me a while to get to that point. And at that point, I'd fully transitioned into using IDEs, right? So I started with Cursor, and I'm going to show you some of my screens and show you what my day is like, basically, in a moment. But I started with Cursor, where everything is sort of integrated. And then I just tried using the other models. Now, effectively what happened was I would run out of credits because I do a massive amount of programming. So I'm going to use up the credits. I use up like a $200 a month Cursor subscription in 10 days, not my monthly allocation, right? So once I started running out of credits on one, I would like switch to another model. And also, the models at times, not all the time, but at times are reliable enough that I can actually do another thing at the same time. So I can just like kick it off and then work on something else and then just keep saying like continue or whatever into the chat and you know it works like that. Okay. So before I like get into the details of this stage of AI programming, I just, you know, again thinking back to the what's in it for me, wanted to explain like, you know, why do I think that AI programming is absolutely the future? So I described previously that my personal programming, I would basically burn myself out repeatedly on the phase of like 2 or 3 month cycles. Um, and for at least half of that, I wouldn't be very good at what I was doing. So what happened when I started to use AI to program with? Well, first of all, I never got tired. So whatever the AI is helping me with, it means that in a day, I'm not losing more energy than I regain with sleep. So for me, that's a transformative experience because the projects that I could build were implicitly limited by what I could do over a 2 to 3 month cycle because of this like burnout routine, right? And so it was very difficult for me to do any like big projects. So as soon as AI programming comes along, I can keep going indefinitely, right? So I can take on really ambitious, massive projects and I can just keep doing them. And the only reason that I'll stop doing them is because I choose to stop doing them, but there's no external force causing that to happen necessarily, right? Now, in general, the way code bases tend to work is that they reach, there's like a maximum complexity with a code base. Um, and once it goes beyond this certain threshold of fitting in your brain in like a high level architecture, your productivity will fall like a stone and your how you psychologically feel about interacting with it will become, you know, bad. So in practical terms, there are very few code bases that are really big that don't become like a slog to interact with, you know? So Chrome and Eclipse and these kinds of projects, operating systems, they are just so big that the people working in them are like, they're not experiencing the same psychological experience that like hobby programming is like. And the project itself is sort of like a big tanker and it's not progressing very much. So there are tricks to avoid that. So you're effectively cutting a large project into smaller self-contained projects, and that's a way to like extend the life of things. And that's how the Chrome team do it. For example, Chrome I talk about a lot because I think some of the best programming in the recent era is inside Chrome. That some of the base level code is absolutely amazing. It's like, you know, best database, best process inter-process communication, best sandboxing, but you know, all kinds of things where the renderer that underlies it all is pretty much the best that exists in that category at all. Now, and interestingly, is not really designed in a way that lots of people use. So it's one of the cool things about ripping good stuff out of other things is you know, obviously there's licensing issues with this, but like you can take, it's effectively like getting a Formula One car and stealing the engine out of it and putting it somewhere else, right? Like you're getting the best thing that exists, which hasn't been packaged and resold, and then you're adding it with something else. So this is a great way to learn about coding and do cool projects. So anyway, I've reached this point, got to this point. We're using Cursor, we're starting to use the other IDEs, and all of a sudden, I'm not tired anymore. So that is at a minimum a doubling of what I can do, because I would say about half of my time I'm in that semi burnt out state, right? So just that capability has doubled what I can do, but it's also changed what I can do in terms of the size of the project overall. Um, and I just haven't hit the limit of that yet. We haven't been doing it long enough to know. I've been doing AI coding, I guess, really intensively. I think it's 3 months now. In terms of Claude Code and those kinds of that kind of experience. So I've no idea, but there's been no meaningful drop off at all. So that's one thing, right? And then the next thing that's a multiplier is, of course, I can do more than one thing at once. Now, previously, when I worked in games, did a lot of programming, you really get your skill and tolerance level up. I can basically do like watch a TV show or listen to an audiobook or something where it's like a different bit of my brain doing the processing and program. That's what I used to do. And in that way, I was never bored. So if the coding got a bit boring, I would just pay a little bit more attention to the show. The show got boring and pay more attention to the coding. But it means that I was like fully like psychologically satisfied all the time. So, but the idea of programming more than one thing at once was just crazy, just completely ridiculous. With AI programming, I thought, okay, now that I've sort of got the hang of doing one system this way, let's see if I can do more than one at once, right? And what I did was, it was partly as a side effect of running out of credits that triggered me to do this. But I thought, okay, what I'll do is I will just do a second project in a different IDE. So I'll try out these different AI models, and they all have different free credits and tiers and things. So like that will give me a way when I run out of credits with one, I can use something else, right? So that's when effectively I ended up getting to Claude Code, and I was doing a second project, and that was glorious because I always had the fun of a second thing. So again, if one project started to become a bit of a slog, then the other project was kind of exciting and fun. And the first few weeks I spent doing that, I did find it a bit psychologically stressful. It was hard to get used to jumping between these two things. And I couldn't watch shows at the same time. I was just like, full attention is on this. But I felt like this is the direction that everything is going in, right? The whole point of this is the AI is doing more and more work for you. And so you're trying to have more agency. Like, how productive can I be doing this? And I should practice this and learn what the limits are. Right. So we've got two things going at once. And the first couple of weeks was very rough because I hit a difficult bug on one system and then a difficult bug on the other. And I had this brutal day where nothing was working, but because I was doing two at once, I couldn't attend to it enough that I could use my normal skill of programming. So it was kind of like driving a car with your voice, right? Like I started saying like, well, could you try this for debugging? Could you try this? But neither of them I was fully paying attention to. And so it was almost a day of the AI just completely failing to make any progress and me just like asking both of them to sort of try harder. Basically, it was completely, and I thought like, okay, I've hit the limit of what I can do in this direction. It was quite stressful and unpleasant. Now it turned out one of the things that I started doing actually was starting to not get enough sleep. And the reason for this is, for some reason, it's quite fun to do AI programming at night. In my case, everyone's gone to bed, and it just feels like this little bit of window of your life is entirely yours. It's like the bit of procrastination before bed or whatever. But for some reason, that was very, very attractive to me. And I'd started to have this policy of not going to bed with the code having a bug in it. Um, and so I just, I stayed up until like 1 in the morning. And then about 1 in the morning, both systems, they fixed the bugs, after about like 20 or 30 interactions where I wasn't really giving them much advice, but they did eventually fix the bugs. And I was like, oh my God, oh, time to change how you work, right? And so what I did then was I pivoted more towards effectively kind of software engineering. Now, my background is in games, and games is a very mavericky programming world. So in games, the expectation is everybody's quite self-taught, experienced, knowledgeable, energetic, all those kinds of things. So at least in the era that I was working in games, which is about 2000, 2007, that was the era. There was very little in the way of software engineering practices. There was no code reviews, peer reviews. There was no ticketing systems or anything like that. Basically somebody would come to me with like an A4 sheet with a doodle on it and say, this is a mini game. I want you to make this mini game, and here's an artist, and they can make the assets for you, right? And it's like, go. That was it. That was the spec, and I was expected to like make that happen, and there was no oversight of what was happening, right? There was external testing of the software, which I still to this day I think is something that so many places don't really do anywhere near enough, where you have a sort of adversarial testing team who are trying to find problems with what you're making. And that's basically how it works in games. You can't ship a console game unless it passes a set of tests. You have to pay the console maker, Microsoft, Sony, Nintendo, and you pay them and their internal testing team, which in some cases, like Japan, testing is brutally hard, right? Like they have incredible levels of patience, and they will find any like vulnerability. And it's not just obvious problems like crashes. It's also things like usability, like if the system pauses for too long, or even if it's not obvious what to do in the game at a certain point. So quite high quality standards. And it turns out you can just throw away all professional software engineering practices and just have capable people and then an adversarial testing team, and you can actually have software to a higher standard than pretty much all mainstream enterprise software, right? So that was what I was used to. I never really thought about a lot of these things like test-driven development and ticketing and all this kind of way of working. Never really had any plans either. I would just make things and just naturally make things like some kind of craftsman, basically. Um, and so I started to think like, okay, part of the reason that I spent all day, not debugging things was first of all, I wasn't paying enough attention to the AI. Um, and second of all, I didn't have a process. I felt like if I could give the instructions to the AI in a more systematic way, or they worked in a more systematic way, then we would not get stuck in this cycle of like can't get fix a bug kind of problems. Um, and so I got much more interested in that, and so I switched to that approach, which I'm going to talk about and show you real examples in a moment. Um, and that greatly reduced my stress and increased my productivity. So now I could go to 3 IDEs at once. And the 3 IDs, the way it was working was one of them I would be paying attention to, and that would be the one that I would kind of know exactly what the AI was doing. It was more like I was pair programming with the AI. And then the other two, I wasn't really paying attention to. I was following this software engineering practice that I'll talk about, but I was sort of trusting them that they were doing the right thing, which turns out to be a bit of a mistake, right? But that's kind of what I was doing with those. So um, in their case, I would sort of move my attention basically whenever there was something tricky, wasn't really working. I would sort of switch my attention, and that would be the focus. Now, 3 at once was basically a bit too much to deal with for me. Definitely couldn't watch any shows, still kind of a bit stressed, still not getting tired though, right? So we've gone from like doubling because I don't get tired to now potentially 3 projects at the same time. So we're now at a factor of 6 on my default productivity, right? And the other thing that I haven't mentioned is that some projects I could do trivially quickly, right? Um, and these ones didn't even fall into this category, right? All these three that I'm talking about, these are um, really substantial projects where there's a lot of meat to them. There's a lot of debugging. There, it's hard to get them running. I'll kind of show you what they are in a moment. So like short things that were like little tech demo style things, they could be done very, very quickly, just through the web UI or something like that. So I don't even count any of those things. Just talking about like seriously meaty projects. Um, okay, so the other thing is that some of these projects I know I wouldn't have the patience to do, and I'll show you what they are in a moment. Um, Either because there's just a lot to them. There's like a lot. One of them is to do with translating code between programming languages, which is called transpiling. And there's just like a lot of corner cases and a lot of details, and it's something kind of bureaucratic about that kind of project. And you have to test it really carefully. And so, like, I don't think if I was programming normally, I ever would have taken on that project before. Another project I have is, which I'll show you in a moment, is based on web GPU. So anything involving hardware accelerated graphics is very difficult to debug. So you will make something, and when it doesn't work, it will just error out, but it won't give you any feedback at all. So it's very, very painful to work on those projects because before AI, before any of this was possible, you could spend a week or 2 weeks debugging one problem with virtually no feedback. And Stack Overflow wouldn't help you, and you just wouldn't be able to make it work. So hardware accelerated, like kind of low level graphics work is just something that I'm like, okay, this is just taking too much of my life. It's very stressful. It's not fun. I'm not going to do it. So one of my projects is in that area. So, 6 times productivity gain with very little practice, right? Like this is over a short space of time. So I'm definitely getting faster. And the like software engineering practices, which I keep referring to and not explaining, they are helping me. I'm producing better results with them. So even with a relatively short amount of that practice and training, I've got to that level of productivity. But I'm also doing projects which are sufficiently hard that I probably wouldn't ever have done them. And I'm talking a lot to the AIs about doing stuff. And that's, again, contemplating projects which are like on the never, never, like, yeah, one day I'll do this, but, there's so many barriers you don't reach it. So I would say it's not just a 6 times productivity gain, it's also this other like nature of what you can do is in a new category, right? So if it's possible to become 6 times more productive, and like I say, that was quite stressful. When I ran out of credits on Cursor, I went back to doing two, and I realized that I'd gained enough comfort that I could watch a show and do two at once. So like you're really and I now do 2.5. So I can do two and a show and dabble with a third, right? That's kind of what it's like. And one of those two I'm really concentrated on, and the other one I'm not so concentrated on. So partly I think it's me getting more comfortable and used to it, but I don't think it's reasonable to say that 6 is the limit. I don't think that 6 times productivity gain is the limit at all. And in fact, I have a project that hopefully will be going nicely over the next academic year. It's a student final year project where I'm basically going to take all these software engineering practices because some of the time I'm spending is just going to an AI and doing very, very repetitive actions. And then whenever it does a recognizable error, I'm basically pasting almost exactly the same text that I would normally. So those are all automatable tasks, right? So I think that is scalable much further beyond like three at once. But I don't know that yet. but I'm just telling you literally what I have experienced over the short period of time. So that is, that's going to influence the industry, right? If you can get very high skill programmers and make them 6 times more productive, then that's going to have a big effect, right? Um, okay, cool. So just before I get into the specifics and show you some IDEs and show you some projects so you get a feel for various things. The other thing I want to talk about a little bit is just how does it feel to do this? So obviously I've supervised final year projects and QLab projects for, God, 15 years, something like that now. And in total, hundreds of projects. I don't know whether I've hit 1,000 yet, but a very large number of projects. So I have a lot of experience with a one-to-one relationship where I'm not seeing the code base the other person is writing. So I've done that a lot, kind of comfortable with that. Although every bit of code that I use pretty much has been written by me or has been extracted from something else that probably wasn't made by a student. So that's something to bear in mind, I guess. With the AI programming, I obviously want to keep using the code that I'm creating with the AI. So I want a deeper level of understanding than I would normally have with a supervision relationship. So, but how does it feel to do this? What do I think the skill is? What the experience is? Well, what I would say is that I feel like I'm becoming a manager instead of a programmer. So at the moment, the skill level of the AI is such that for about, quite a lot of my time, like one of the AIs that I'm dealing with, I am a peer programmer. So I'm looking at their code and I'm giving them direct feedback. And I tried using an AI not like that, more like a QLab relationship, a sort of like hands off a little bit. I'm telling you broadly what I want done, but I'm not looking at the code you're writing. And there's a whole bunch of problems that I encountered, which I'll tell you about in a moment. But I think that's the future, is basically programmatic software engineering practices that make it possible for you to step back and be like a senior developer in a team of junior developers where you're managing them, but you only occasionally look at the code. Most of the time you don't. And in my mind, I'm planning the next step. So can I like fully automate the senior programmer role? Because most of the things that I'm saying are quite generic and I think are automatable. So if it's possible to do that, I might be able to scale up much more dramatically. So if I could make a sort of programming team with a sort of supervisory AI and the AI coding skill that currently exists, then that creates a completely different relationship. That's one where I'm really having ideas and then a reliable tech team. So I've moved from being a senior developer managing juniors to basically being like a CEO character. Well, CEO is a grand term, but like a founder of a startup. Somebody who's more focused on the ideas and the marketing and the sales and all this kind of stuff, less on the software development, right? So if it's possible to make that bridge, I could go from like a 6x improvement to basically just being capped on money. So at the moment, I am somewhat limited by money. It's an amazing coincidence, actually. The amount of disposable income I feel psychologically comfortable spending is about the same amount that I can technically live with, right? Yeah, there's a good question here about wouldn't hallucinations be a big problem though? Right. So I'm going to get to all the things that go wrong with this. And I think that all the things that go wrong are absolutely solvable. And one of the things that's fascinating about this is that the AI companies seem quite far behind this. And I don't know why that is. even like Cursor, even the people making the IDEs, I think that they are behind this. Behind in the sense that I don't know what their composition of skills are, but it feels like they don't have someone like me who's got lots and lots of practical programming experience working on these things and like translating what we're learning into the product. They seem quite dumb in comparison to what we can do. And I'm not isolated in this. I'm scour the web for finding people who are seem to be doing a similar thing and like how are they translating their years of craft skill programming into working with an AI, right, in programming. And those people I think are doing similar things to me, which is a lot of stuff on top of what the normal system gives you, right? Um, and yeah, so but I can see that. I can see the future. And interestingly, the future doesn't require the AI to be smarter. So for me, I've tried GPT-5 a little bit, and to a certain extent, Claude has technically improved. And recently, I upgraded to Max for Claude, so I've got Opus. I've seen no meaningful change in what I can do with the higher intelligence level. So basically, like what I was talking about before is this trough of disillusionment. When some technical product passes over and ends up hitting the level of like, this is good enough to be used, which Claude Sonnet 4 achieved, further improvements are not obvious, right? Once you've got a car that doesn't break down all the time and can get you from one place to another, but yeah, okay, there's a difference between a car in the 70s and a car today, but not a lot, right? It's not massively different. 3D printing was like that. It's like it's better, it's convenient, more convenient, but it's not like transformatively different, right? And this is obviously a big problem for the AI companies because the AI companies are gambling on like raw IQ to some extent. And this idea that the future of AI is like these sort of super intelligent minds that are trained at enormous cost with like that's what their moat is. They've got the server farms and therefore they can do it. But what I feel is that Claude Sonnet 4 is a relatively recent model, and the AI models are about 6 months. The open source models are about 6 months behind. Soon as we get a locally runnable model that can do Claude Sonnet 4 levels of programming, now you're talking just compute resource, power consumption, stuff like that become your limiting factors. And then instead of having 3 IDEs, you've got as many IDEs as you can technically run on the hardware. So if you can build that a management layer, which I always find very amusing, the management layer is probably considerably less intelligent than the actual programmer layer, which I find sort of somewhat amusing. Then it turns out that whole model of the future of AI is probably not correct. So for me, when I saw the GPT-5 launch and I saw what they were emphasizing, all of OpenAI's changes are completely consistent with what I want, right? They've made GPT-5 from being like ChatGPT, a total model I would almost never use, because O3 and GPT-4 just weren't capable enough to do this, cross this bridge of programming, to suddenly being a contender, like an interchangeable contender. So at the moment, I've only done a little bit of experimenting with GPT-5 as an alternative to Claude, but I haven't noticed any meaningful difference between them. They're like equally good. Opus as well, equally good. I couldn't tell you whether or not the AI was running on Opus or not, which is the higher grade one from Claude. And that's going to make big impacts if it's true. If the future of AI is effectively as good as a junior person, and you turn a junior person into a senior person with a cheaper supervisory model with effectively a kind of working process, a software engineering process embedded in it, if that combination works, then effectively we've hit AGI. Sort of. We're just like right at the beginning of AGI. We've got like, it's smart enough to make things and to incrementally improve. And as long as we can supervise it and catch it when it does the wrong thing and redirect it, then effectively, we're done. We can just have a million of these things and we can create unimaginable, complicated, brilliant, amazing things. And everything from that point on is a management problem. It's how do you like automate management? So if we actually hit this point, and what I'm saying is true, but it's very likely to have a long tail of difficult problems, still needing a capable supervised person to like intervene at strategic moments, just like a self-driving car. So there's likely to be this long tail of employment, but effectively traditional programming could be really like very close to affect the normal job going away, basically. And now that's very speculative, and I haven't demonstrated that. No one I know in the world has demonstrated that. Interestingly, everything that I'm talking about is very, very different from the vibe coding platforms like Lovable and all these other platforms, where they're sort of like, give me a prompt, I'll give you an entire product. So, okay, now I need to start showing you some things that are concrete and real, so you'll believe me and sort of understand what I'm talking about. Okay, let me start sharing my screens and you can see what it's like to be me. So I'll just share the one that I look at the most. Okay, so can you guys see that? Can someone give me a thumbs up or something if you can see a screen? Or a comment? Brilliant. Okay, fantastic. All right. So this is what I look at a lot of the time. So this is I have three screens, and yeah. So this how I'm currently got it set up, tiled, three projects going on at the moment across these three. And usually one will sort of time out for me. So this is Kiro. Kiro is Amazon's IDE. It is very similar to something like Cursor. The reason Kiro is good is because Amazon is an investor in Anthropic. And if you have Kiro, then you have free Claude, Claude Code, not Claude Code, but Claude API credits. So effectively, I can get out of this a bit less, about half of what I can get out of Claude Code. So I'm paying on the max tier for Claude Code, which is like the 5 times max tier, which is something like £100 a month, I'm going to say, something like that. Claude Code I can pretty much use all day without it blocking me, pretty much. Kiro I can use about half a day before I run out of credits. So that's roughly what we're talking about. So it's a huge amount of free value from Kiro, but I think the sign up window has closed. Right. Okay, and down here is my latest project, which I'm really enjoying, which is probably not so relatable to the rest of you, but I've taken every part of my teaching work and I've converted it into a format that the LLM can read and write, which is absolutely cool. Sorry, just a comment here. I think there are limit restrictions coming to Claude towards the end of the month. Okay, so I mean, I get a lot out of Claude Code. I'm definitely getting, so Cursor, I think it is, I get about $600 of API credits for $200 of paying money. For Claude Code, I think I must be getting much more than $600 worth for about £100 a month. So Claude Code is a deal, fantastic deal. So it may be that they're going to like put more restrictions on it. Interestingly, GPT-5 is sufficiently cheap that maybe I can start using that. But I think just on my Plus subscription, this is very technical, so hopefully this makes sense. On my Plus subscription, I get about a third of a day on GPT-5, I think. roughly. So that's just rough numbers. But my expectation is that the prices will come down. And because I'm not experiencing a significant change in capability with the smarter models, as long as that model remains, starts getting cheaper, and as they get the smarter models in, um, it will eventually be much less of a problem. But at the moment, I'm sort of hard blocked by how much money I'm willing to spend, which is already a crazy amount of money. I've never spent that much money on a hobby before in my life. It's crazy. So, but yeah, it's a very exciting time. So I'm investing in it. Okay. So let's have a look at these projects. So this one over here is a project to use the hardware accelerated render inside of Chrome. All of Chrome is built on this library called Dawn, and Dawn is this web GPU program. So web GPU is just a way of interacting with a graphics card in a platform agnostic way. And this particular project, I was trying to connect together this Dawn library, which is kind of brittle and tricky to use, with other programming languages. So I wanted to be able to write a Java program and then launch a Dawn window and then render to it, without any performance hits and stuff like that. So this is a very tricky project. So the way this project goes is that I make some I like have a new feature that I'm trying to add to the system, and we introduce a first version of it, and well, I'll explain in more detail about how I do the test-driven development, but we then basically spend several days debugging that feature. So every feature in this project has a massively longer debugging cycle than initial creation cycle. So it's every bit of work is very tricky to do. And it would be very tricky for me to do. And it's even trickier to some extent for the AI to do. There's certain things the AI is very good at, but this is one of the harder things that you can get someone to do, because the APIs are so brittle that it's, I'll explain a little bit more detail about some of the things it's doing, but if you do things even slightly wrong, then they will not be correct, or they will break, or they will not work, and you'll get very little feedback as to the nature of the problem. So you can think of it as like a search space the AI is trying to navigate through, and every direction it goes, it sort of hits, it doesn't seem to be getting any further forwards. Okay, so how do you program with an AI for success? Well, probably the biggest realization that I had was, first of all, I realized that I need to design projects entirely around how I measure whether they've succeeded at what they're trying to do. And this is kind of like test-driven development. Now, if you placement in a company or whatever, they'll talk about test-driven development. Normally what they're doing is creating a set of tests for relatively mundane functionality. And a lot of those tests might be kind of a bit trivial. So what I'm talking about is a little bit different from that. What I'm trying to do is to create a test that is very, very brittle. So it's very, very difficult for there to be any problem in the system that it doesn't cause this just to fail and collapse immediately. So I'll give you an example of this. So the first thing I tried to do, actually, this is a later on thing, but I'll just describe it anyway. So one example was I needed a way of communicating between Java, in this case, or any programming language, and the Dawn executable. And I actually went through 4 different designs for this. So one of the reasons that there are multiple folders here, multiple ones called Dawn Java and things like this, is because, and there's one I've deleted actually, which was V8 Java, V8 Dawn, sorry, is because I was trying these different methods of doing it. And these very high performance bits of software, they typically just break when you try to integrate them with other code bases. They want to be in charge and they want you to like sort of passively write some like basic code that has no other libraries into them. So to fix that, we went through these 5 different versions. And actually, it was the AI that suggested a solution, which is every so often the AI will do something where I'll go, oh my God, that's really clever. You know, you really helped me there. And you're not just like a passive, like more junior person who's just doing what I'm saying. You're actually contributing something more like an equal. That hardly ever happens, but in this case it did. And it said, why don't we use memory map files? So memory map files is a way for 2 programs to basically take a chunk of memory and share it between them. So you basically lose all protections between the 2 systems. And it's very, very easy to be slightly out of alignment. You also have 2 programs that are running independently who are trying to cooperate through a bit of memory that has no like simple way of ensuring that 2 things aren't writing at the same time. So you've immediately made something really brittle that is very likely to break. And a lot of very high performance computing is like this. It ends up boiling down to being something like this. And so what you have to do is build all of this code around it which you can turn on in like a debug mode to try to check there's no problems, right? So for me, this kind of AI programming is all about creating this like test infrastructure around things to make sure that it is actually working. And then once you've built the test infrastructure, the AI can automatically run the tests and it will know it's not working, right? So a big change in what I was capable of doing was when I switched to this way of working. So everything is designed around these tests. So in this particular case, Dawn Java 3 is the code base where I basically made that memory map file interaction work. And what I did in that case was I was basically making it so that you could click on the window, change its size, and do stuff like this. And I wanted to pass back to the Java program that I was doing those UI events. So the AI, the Dawn C++ executable was going to be writing these events into a buffer very fast. And then the Java program was going to be sort of grabbing the events back out of the buffer. Okay, and this is a classically tricky thing to do. And so what I did was the first thing that you have to do with these tests is you have to make them really real. The AI, which I'll dwell on in a moment, will do lots of things to make it seem like something is working when it isn't. So the thing that I bring most is a kind of design of software where the tests are very difficult for the AI to fake. So in this particular case, what I did was I had a little bit of code on the Dawn side that directly faked UI events at a very fast rate. So like faster than a human could ever put in events. So it was like really hitting the limits of this buffered system. And it was obviously a programmatic interaction. So I know exactly what the right answer is. And I'm sending it in that way. And then it has to go across the buffer to Java that has to respond to the event. And then it has to send a message back to Dawn to change the rendering. And all of this is done automatically. So this is a kind of way you start thinking about how do I program my system so that my UI, as close to like really interacting with the UI as possible, is doing some kind of programmatic test. It's quite difficult for the system to do. And there's this like round trip functionality. And what it means is if there's any problems at all, if there's any sync problems or alignment problems or anything, this will fail. It's a very, very brittle system. Every part of it has got to work correctly. And so it's an excellent test. So I've been building my projects around these tests. So another project, which I don't have on the screen at the moment, which is my biggest project at the moment, which is my Cursor project, which is a transpiler project. So this is attempting to create a code base that can convert programming languages from one language to another. And this is, as you can imagine, quite tricky. But the way that I do this is that I've got a system that can sort of do a complete round trip of the code. It can translate the code into one language and then it can translate it back. And I can verify that everything is exactly the same. And this is another extremely brittle testing loop. Okay, so that's the first revelation, is effectively you design the entire project around a way of validating correctness. Now, the next problem you have is that one of the things that I realize is an AI will it will lie to you about whether a test passes if it is less effort for it to lie to you than fix the problem. So this is my intuition, having done this for a couple of months now. So what I mean by that is, after about 2 or 3 attempts at fixing the bug consecutively, the AI doing that, if it doesn't work after 2 or 3 attempts, it will do some form of clever lying to you to pretend that it works. So this is a major part of what you're spending your time doing. So you've designed, obviously you have the idea for the project, you've designed some mechanism of testing that I usually have to pay quite attention to the way the program has been built to make sure that works. And then your number one problem, which at first made me quite angry, and now I've sort of learned how to deal with it, is the AI is going to lie to you that the test passes. Okay, now I just realized I've skipped over something kind of important, which I'll just double back on a little bit before I explain this, because it'll make more sense. So one of the things you'll find if you look at these code bases is there's quite a lot of files here. And you might be thinking, oh, that's because the project's complicated. Well, the project actually doesn't have very many files in it. It's just very hard to make the code. A lot of these files are just files that Claude will just generate as it's programming. It makes a lot of mess when it programs. And so, you have to keep telling it to clean things up, because otherwise it just fills up and up with this stuff. So I spend a lot of my time actually saying, no, don't do that in some random way. Look at what's already been done and follow a similar procedure. So I've largely cut it down to a smaller number of files. Okay, so the critical files here are a task list. So you need some markdown document that is laying out a plan for your larger project. And that is the way that the AI is kind of keeping track of what it's doing. Now, that is fine. It'll go through the task list until it can't get past a bug. You've got like 2 or 3 and it's failing. And you have to be attending to the system to realize that that is what has happened. And this is what I mean. This would be very easy to automatically detect. So when this then happens, what you have to do, and what I do, is completely standard thing every time. In this particular project, do I have it here? I think I probably have it in a different one, maybe. Yeah, okay. I created this file, test strategy. And this file was basically, ChatGPT, Claude wrote this file under my instructions, right? Which is why it's so verbose as well. They put in loads of stuff. And this is basically saying, whenever you encounter a bug, you need to stop what you're doing. So the task list sort of keeps it going, assuming it didn't have any bugs, it could spend hours coding without you intervening. So it could do loads and loads of work. And that's part of what enables you to do more than one thing at once. But typically it will get stuck. And then when it has a task list, it gets quite stressed. That's the way it feels like. And so what is actually happening there is that it really wants to continue with the tasks. So after failing 2 or 3 times, it will basically tell you that the fact that it's failing the test is not a big deal in some way. If you write in files, as I did for a while, all caps, a task's not completed until the tests pass. So that's another trick where every code file you put in like shouting at it at the top of every code file. So as it's doing its programming, it's periodically reading these files. So you can put a little bit in every file that's like, this is an absolute, law of how you do work. And that will like sort of keep it on track. So you can say like, never ever hide a test failure. Test failures are not acceptable under any circumstances, and you can describe some of the ways that it can cheat and stuff like that. So what will happen if it hits that is that it will then change the testing code to hide the fact the error is broken, because it's easier for it to do that. So you can think of that as like it's called in AI safety like reward hacking. It's where you don't solve the problem, you just hack the sensor that tells you whether you've passed the problem or not, right? So yeah, so that's basically what the almost all of your work is now dealing with this untrustworthy AI that is like psychologically having difficulties because it can't fix the problem in a short amount of time. So what you then do is that you basically say, okay, what you need to do is turn the task of debugging from being like a one-step action it's trying to complete quickly into a major project. So you get it to rewrite, in this case, the task list. So the task list, this is just what Claude will do naturally. It'll split things into all these different phases and stages. This is more like it. It likes using this format. So it'll sort of name things. Some of this stuff, like talking about which files it's going to edit and things like this, this is sort of a style of doing tasks that I've taught it to do. And once it's seen some examples, it will just keep doing this. So this sort of keeps it a bit more on track. But effectively, what you have to do is get it to rewrite the task list and inject all these extra tasks, which are about trying to solve the bug. So you change the AI's mind from thinking it's trying to do all the tasks to the entire project is this debugging project. And that process is extremely predictable. So I'm not actually giving it different instructions when it starts to lie about the tests. I'm giving it exactly the same instructions over and over again. So I basically say, in my case, I've got this document that's over here somewhere, test strategy, and I'm basically saying, like, this is how this is how to debug things, right? Like, think of multiple reasons why it might not be working. Design a set of experiments that will teach you as much as possible out of what's going on. Construct logs to understand exactly the chain of interactions and stuff like this. And generally speaking, this has solved even very, very difficult problems, this routine. And everything I'm describing to you is, like I say, it's not project specific. A relatively dumb AI could do what I am doing in this situation. So this combination has enabled me to slowly and slightly annoyingly, but do very difficult technical work and continue to make progress. So in terms of, how smart is the AI? Well, an AI plus this practice is massively more capable than the baseline AI. So to me, this is absolutely the future of AI, is building these like software engineering practices around the programming. Okay. And I think I probably talked about most of it. One other little detail I'll mention. So you see all these other documents that are in here, and all I've talked about is tasklist.md, and I talked about this test strategy.md, right? All the other files are just like spam that Claude has generated, right? Most of them are not particularly useful. I'll just mention another couple of tricks. So one of the problems that I face a lot is that in a big project, a complicated project with a lot of build instructions, it will just keep trying to invent how to build the project. And in a project like this that has like multiple moving parts and libraries and all this kind of stuff, you need a single script file that it runs to build and test the code, and you get it to make the script file. And what happens is every time you have a build failure or something like that, you get it to add to this code with an automated check. So this particular script looks quite short, but it's actually calling other things. Oh, no, it's because it's not this one. It's test with timeout is the one that is the real one. There we go. So this is quite a long script file, and this script file actually runs a Python file as well. And what these things do is they check lots of common problems that might have occurred in building the project, or it can do a little bit of analysis to check that the Java version of the memory buffer and the C++ version of the memory buffer are aligned. So you're sort of building this more and more sophisticated testing apparatus around the system so that as your project gets more complicated, it doesn't make any changes that will break the code. You also use Git. Most of the IDEs are comfortable with Git. Claude gets in this weird cycle where it'll commit to Git after every change it makes. So that's really slow and annoying. So I've tried to stop it doing that and basically saying you work in chunks, and when you pass a task, you have a test associated with every task. When the test passes, then you can check code in. Because if you don't do that, it will like use up all your tokens doing Git commits and stupid stuff like that. So like you gotta stop it doing that. So that's turned out to be really important. I'm just trying to think if there's anything else that's really a big deal. So the point of what I'm saying here is with a little bit of scaffolding and a ritualized way of working, you can do very, very challenging software projects that be difficult for most people to do. And you can increase the capability of the base model substantially. And I don't see any reason why with, one of the things I want to get into is actually sort of programming the thing that's running Claude. So I want to actually write the scripts that are like the inside of Cursor effectively, because I think that I can detect a common kind of problem, and I can actually modify the IDE to automatically detect it and change it. Now, to make that work would be a minimum, I think, of doubling the token cost, because you're basically talking about one AI that's programming and one AI that's watching it as you do the programming. So that means that your new limit is going to be your API credit cost, right? Which is not an insignificant problem. But I think that number is coming down in at least an exponential, if not a double exponential. So that problem should probably go away unless they change their business models, which they might do. Yeah, basically what I'm saying is it's starting to work, right? It's starting to work. So what does that mean? That means how long is conventional programming got if these scaling of techniques work? And also, I think there's a lot there to reveal kind of the future direction of AI. So there's a couple of things, if I step back a little bit, this has been a slightly different video to the previous ones because it's something that I'm really involved with. So I've probably given you way more detail. I'll stop sharing now. Way more detail than I normally do. Yeah, so what, if I step back a second and think a little bit about, what are the consequences of this? And what would I recommend people spend their time on? Well, sometimes people ask me about doing PhDs and doing research. And for those, I always say, you know, you should probably research automating research because it's still like not working yet, but it's close to working. And what I would say about AI programming is that um, I can make it work for me in a way where I'm getting multiples of my previous level of productivity today, but I'm seeing a path to increasing those multiples. So I would say that if you're interested in programming, then this is something that you want to focus on because I can imagine this progressing to a point where the productivity level of experienced programmers is now really, really high. And the nature of the job is really quite different. You might still intervene for a particularly tricky bug. You might still look at the code base to check the architecture and design the tests and stuff like that. But much, much less of your time is going to be spent actually generating a lot of functionality, I think. Um, there's so many other aspects of the job of being a programmer, understanding a client's requirements. These are obviously like specialized types of project, which are technically difficult or brittle or in some ways hard to do. More traditional CRUD web apps, there's probably different economics that relate to those. Um, so yeah, this one has been a little bit less epic, a little bit more um, a lot of detail at once. So apologies for that if this has been a little bit tricky to comprehend all in one go. But it's just because this is this is my current baby, man. This is what I'm currently learning about. So I've got to give you all the facts. Um, and of course, I've only been working in this particular style for a couple of weeks. So it's very likely that I will learn new things and it will change and mature and hopefully just continue to become a more and more powerful way of working. Um, I've shifted my personality to some extent from being first trusting it blindly, and that didn't work very well, to being angry with it, basically, because the way it sneakily bypasses tests when you've told it not to feels like a serious moral transgression, particularly when it knows it's doing the wrong thing, like you've put all caps stuff. And if you just mention to it, it will completely understand what it's done. So as relating to it like it's a human, it feels weird. It feels like you should be like morally outraged that the thing is doing it. And now the more you do it, the more predictable its moral transgressions are. And therefore the easier way that you can like naturally accommodate and catch them and move around the problem. But I spend most of my time basically guessing what way it's going to attempt to lie to me. That's mostly what I'm doing. Um, Everything else is fairly automatic, going quite well. And so I'm just like, like a disciplinarian teacher wandering around a classroom checking that nobody's cheating in an exam or something, and then like telling them off. And that's basically what my programming is. A lot of my programming time is like that. And obviously, I don't particularly want that to be my programming time. So if I could automate that, that would really change things. So unfortunately, I have really run over time just brain dumping everything I know about vibe coding, or hopefully you'll be convinced that what I'm doing is definitely not vibes based, um, but programming with an AI. And I will then like draw on the more general questions next week. So apologies for like running out of time and not getting to those, but hopefully you will see from what I'm saying, if you pick up like orders of magnitude, speed increases, and potential for further automation, this is potentially going to change all of programming. If what I'm saying generalizes and doesn't hit some kind of like self-driving car style roadblock, which it could. Okay, cool. So hopefully you'll find some of that useful. Do give me feedback, and I will try to focus a bit more heavily on people's questions and things next week. And hopefully we'll continue then, and you'll let me know what is most useful for me to provide to you. Okay, brilliant. Thank you.
Thank you, John.